Hello everyone, my name is Guruprasad KN, working as Assistant Professor in the Department of Electronics and Communication Engineering, ATME College of Engineering, Mysuru. In this video, I will be demonstrating how to design and verify a RC phase shift oscillator using Multisim. So the aim of this experiment is to design and verify the operation of an RC phase shift oscillator using Multisim and to determine the phase shift contributed by each RC network stage. The objective of this experiment is to simulate the RC phase shift oscillator in Multisim and will observe sustained oscillations and measure the individual phase shifts and the total phase shift produced by the RC stages. This is the circuit diagram. In the circuit diagram, I have used a op-amp. Commonly used op-amp is MUA 741 and I have used 4 resistors, 50 kilo ohm, 1.9 kilo ohm, 1 kilo ohm and other one is also 1 kilo ohm and 3 capacitors 0.1 microfarad each. And to observe the output, I am using virtual oscillator. So let us construct this circuit using Multisim. So let me log into the Multisim. So first let me choose op-amp, press Ctrl W. You can go to all families and you can type 741. Go to all families or all groups 741. So you can drag and drop this one. And I require resistors. So I'll go to basics, choose resistors. Total I require 4 resistors. So I will pick 4 and I will keep. And I require capacitors also, 3 capacitors. So I will pick 3 capacitors and I will place here. And we require power supplies. For the power supply, let me go to source, power source, choose VCC. And since I am using op-amp, I also require negative power supply, that is minus VEE. I also require ground terminals. So I require 2 ground terminals. And I also need oscillator. So now let me connect all these things. So before that one, so this VEE I am connecting to the pin number 4. Before that one, let me rotate. You can use Ctrl R option. And for pin number 7, I am connecting plus VCC. So let me change the value to 12 volts. Similarly, minus VEE, minus 12 volts. And this resistance, again let me rotate this one, Ctrl R. So this value I am choosing it as 1.9 kilo ohms. And this one, let me take it as 50 kilo ohms. And let me rename it as RF. And again, these capacitors, let me choose 0.1 microfarads. And these resistors, I'll rotate this one. So let the values be 1 kilo ohm. and I need to connect pin number 3 to ground. So let me start by connecting pin number 3 to the ground, and pin number 6 I will connect it to RF. Other end of RF I am connecting to R2, and pin number 2 I am connecting between RF and R2. Let me connect C1, C2 and C3, again R3 and R4. Let me ground this R3 and R4, and connect C3 to the pin number 6. Now both the negative terminals of CRO connected to the ground. Channel A I am connecting to the pin number 6, the output, and channel B I am using this one after first RC section. Let me change the color so that I can easily differentiate between input and output pins. Now the circuit is completed. So what I am trying to do here is I will simulate this particular circuit diagram. So it will take some time for the oscillations to set up. So meanwhile, let us understand in the pin number 6, that is what I have connected to the channel A, whatever the output I am getting, that I will consider as a reference waveform. Then whatever the output I am getting after C3, that is in channel B, that I will compare with the reference waveform and I will check whether there is a phase shift or not. So with respect to the reference waveform, if I observe after first RC section, then there will be a phase shift of 60 degree. So instead of connecting after C3, if I shift this wire after C2, then there will be a phase shift of 120 degree. And if I check the output after C1, then definitely there will be a phase shift of 180 degree. So the meaning here is each RC section will introduce a phase shift of 60 degree, and total there are 3 RC sections are there, and the total phase shift will be 60 into 3, that is equal to 180 degree. Now we will observe the oscillations are getting set up. So you can observe on the screen. Let me reverse it. So slowly oscillations are setting up. You can clearly observe how the oscillations are set up. So red color one is the reference one, and the blue color one is shifted version. So let us pay the close attention towards the screen. Now oscillations are built up. After some time they will be sustained. So the oscillations are almost sustained now. Now let me change the time base so that I can see it properly. Let me click on single to stop this one. Now we have two waveforms here. And the red color one is the reference one, and the blue color one is shifted version. Now let us understand how to check the phase shift here. Now first let me ground channel B. So let me click on 0. That means currently I am observing only the channel A, that is the reference value. Now I will take this point from here to here, that is one complete cycle, that is equal to 360 degree. So for 360 degree, how many divisions it is covering? So in one box we have 5 divisions, which is equal to 0.2. So from here to here, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6 and 1.8. That means to cover 360 degree, it is taking 1.8 divisions. So 1.8 divisions equal to 360 degree. Now let me enable the next one. So the next one is a blue color one, which is phase shifted version. Now I have to identify what is the difference between these two, or you can take any two. So here it is greater than 0.2 and less than 0.4. So approximately it is equal to 0.3. Right? So now let me write on this one. So for 360 degree, it has taken 1.8 divisions. For 0.3 divisions, how many degrees? So for 1.8 divisions, 360 degree. For 0.3 divisions, let me take it as x degree. So x equal to 0.3 into 360 by 1.8, that is equal to 360 degree. Sorry, 60 degree. Now, similarly, instead of checking the output after first RC section, now let me check after second RC section. So let me change the color to the blue. Let me run this one. Again, it will take some time for the oscillation to set up. Meanwhile, let us check the theoretical output. So what we can see here is, so this is what 60 degree phase shift what we observe. So 120 degree we can see the difference between the red color and the blue color will increase. So earlier it was approximately 0.3 divisions. Now it is almost doubled, that is 0.6 divisions. So now we can write 1.8 divisions 360 degree, 0.6 divisions how many degrees? Let us check. The waveforms are still building. It may take some time. Let us wait for that one. Slowly oscillations will build up. You can see now here the oscillations are getting set up here. Pay attention closely. The red color one is the reference waveform and the blue color one is 120-degree shifted version. So let me increase the amplitude. So now you can see, let me disable channel 2. So this will not change. It is similar to the previous one. That is, it is taking approximately 1.8 divisions. You can see starting from this point till the completion of 360 degree, it is approximately equal to 1.8. So 1.8 equal to 360 degree. Now if I enable the next one, then you observe the difference between these two. So the difference between these two is approximately 0.6. Right? 0.2, 0.4, 0.6. Approximately it is 0.6. So similar to the calculations what we have done earlier, that is 1.8 divisions 360 degree, 0.6 equal to how many? So that will be approximately 120 degree. Now once we complete this one, next, so let me connect this line after the third RC section. Let me change the color to the blue. Now let me run this one and double click on the oscillator. Now let us wait. Again, it will take some time for the oscillations to set up. So here the difference between the original waveform and the shifted waveform will increase compared to the previous two. So similar to the previous two cases, here you will be finding the third one. So meanwhile, till the oscillations get set up, let us see the waveforms once again. So this is 60 degree phase shift and the second one is 120 degree and the third one is 180 degree. In the 180 degree you can see they are exactly opposite to each other. So this is what the calculations for 60 degree in the same fashion. So for 120 degree, so this 0.3 will be replaced by 0.6. So y will be equal to 0.6 into 360 degree divided by 1.8, that is closely equal to 120 degree. Finally, we will write the tabular column and we will note down the values. So after first stage, the theoretical value is 60 degree and the practical value will also be 60 degree. Similarly, after second stage, it is 120 and the practical value is also 120. And after third stage, let us wait for some more time to the oscillations to set up, and we can clearly see after the third oscillations, both the waveforms, the original waveform and the shifted one, that is after the third RC section, both will be exactly opposite to each other. That is 180 degree phase shift. Now you can closely observe how the oscillations are set up. And if you see here, so both the waveforms are you can stop this one and you can see the red color one is reference one, blue color one is shifted version, and clearly we can see here there is a phase shift of 180 degree between those two. and you can also do the calculations in the similar fashion what we have done earlier. So this is how we will going to check the different phase shifts in RC phase shift oscillator. Thank you for watching the video.